In this video, we want to find the integral of x cubed plus x plus 1 over x to the fourth plus 2x squared plus 1. Notice I can rewrite this as using partial fraction decomposition as x over x squared plus 1 over x squared plus 1 quantity squared. So I'm going to skip the steps for partial fraction decomposition, and so we'll just continue from here. Now I can split this up into two separate integrals. The first one, I'm going to let u equal x squared plus 1, du is 2x dx. So I'm going to divide both sides by 2, get 1/2 du equals x dx. So that's what's going to go over here. Replace x dx with 1/2 du, and then the 1/2 I'm just going to factor. And so that's going to be du over u, which is 1/2 ln of absolute value of u plus c, and u we said is x squared plus 1. So technically, because it's an absolute value, x squared plus 1 is always going to be bigger than or equal to 1, so I don't need the absolute value. Okay, now we'll focus on 1 over x squared plus 1 squared. So for that, we're going to make a substitution. We're going to let x equal tangent theta. And so dx is secant squared theta d theta. So dx on the top will replace with secant squared d theta. In the denominator, we have x squared plus 1, which is just tangent squared plus 1. And then the whole thing squared. Tangent squared plus 1 is secant squared, and then we're going to square that. So secant squared over secant squared squared, that's going to give me 1 over secant squared, which I can rewrite this as cosine squared. Okay. Now from here, I'm going to use a double angle identity. So we're going to rewrite this as cosine 2 theta plus 1 over 2 d theta. And then we're factoring out the 1/2. Integrating with respect to theta. So cosine 2 theta will be sine 2 theta over 2. And then 1 will just be theta over 2. Now we want to replace theta. But before actually we replace theta, notice that sine 2 theta is 2 sine theta cosine theta. That's going to be over 2 plus theta over 2, and then the 2's are going to cancel. I'm left with 1/2 sine theta cosine theta plus theta over 2. Okay, now we need to replace what sine theta, cosine theta, and theta are. So we'll go back here. We said x was tangent theta. So if we draw this out, so draw a right triangle, call this angle theta. Tangent is opposite over adjacent, so I'm going to put this over 1. That means the opposite side is x. The adjacent side is 1. Pythagorean theorem says the hypotenuse is square root of x squared plus 1. So if I'm looking for sine theta is opposite over hypotenuse. That's x over the square root of x squared plus 1. And then we have cosine theta, that's adjacent over hypotenuse. And then to solve for theta, well, if x equals tangent theta, that means inverse tangent x is equal to theta. And we'll put that over 2. Now we're simplifying. We still have the 1/2 outside, and we have the square root of x squared plus 1 times the square root of x squared plus 1. That's x squared plus 1 with the x on the top. And then we can distribute the 1/2. That's x over 2x squared plus 2 plus inverse tangent of x over 2. And then obviously we'll include the plus c. But the plus c, we would grab it from this one since we already have it. And so we'll have 1/2 ln of 2x squared. 1/2 ln of x squared plus 1. Okay, so this will be our final answer.